Hi guys, hope everyone is doing all right. Day two on being home from school. Um, I'm gonna go through these notes of the rational functions, and then go through the first homework assignment that I gave you. Okay. Most of this information we did before break. We did, the, I think Wednesday, Thursday, Friday before break. Okay, we did plenty of examples where we came up with the domain. Okay. Rational functions are functions with a numerator and a denominator, okay? Fraction, where we have a polynomial divided by a polynomial. We should know from earlier in the year, when we take the domain, we try and find the domain, okay? We're looking at where this function would not exist, which would be when our denominator equals 0. So our domain would be all real numbers except for when our denominator equals 0. So when our denominator does equal 0, that means we're either going to have a whole or a vertical asymptote on our graph, okay? Because we can't have an x value there, so it's either going to be a whole or a vertical asymptote. Okay? When the factor can cancel out with something on the top, okay, which I'll show you when we look at an example on the homework, that is when we have a whole, and when it can't be canceled out, that is when we have an asymptote. Okay? Then when we look at our horizontal asymptotes, okay, I gave you this form. We wrote it on the board. Sorry, it's a little messy there. But when we're looking for a horizontal asymptote, we're just looking at the first term on the top and the bottom. Okay? And there's three different scenarios that we have when the degree or the exponent on the top is less than the bottom. We have a horizontal asymptote at y equals 0. When the degree on the top and bottom are the same, we look at the coefficients out in front and we have it at y equals a over b, the two coefficients out front. Okay? And then whenever our n is greater than our m, so the degree is greater on the top than the bottom, then there is going to be no horizontal asymptote. Okay? It always follows these three rules here, so we need to know these three rules. Okay? I did an example out here for you. I'll just quickly explain this before I get over to the homework assignment. Okay. What we first want to do when we're given an example is we want to factor them. Okay. So we have to factor both the top and the bottom. When I factor the top here, it factors to x minus 2, x plus 1. What I can see is when I factor the bottom, x plus 3 times x minus 2. You can see how we have x minus 2 on the top and bottom. That is where we can cancel it out. Okay? So we can cancel out x minus 2 and x minus 2. So what that gives us is going to be a whole. This x minus 2 equals 0. When we solve that for x equals 2, that is going to be a whole in our graph. Okay? We can see here that this x plus 3 cannot cancel out with anything on the top. So it's going to be a vertical asymptote. We set it equal to 0 and solve it, and we have a vertical asymptote. Okay? So both of those are part of our domain. All real numbers except x cannot equal negative 3 or 2. Okay? But negative 3 is a vertical asymptote, 2 is a whole. For our horizontal asymptote, we are going to look at the exponents of our first term. We see how they are the same, 2 equals 2, so we are following n equals m. So we're going to have a horizontal asymptote at a over b, which would just be the numbers out in front, 1 over 1. So we have a horizontal asymptote at y equals 1. Okay. I think that example might have even been a little more difficult than some of these on the homework. Okay, but we'll take a look at these now. Okay. I'll also send this to you so you can have this as a copy on Google Classroom. Okay. If we look at this one, okay, there's no factoring we have to do. So what we would first do is try and figure out when the bottom equals 0 to find our domain in our vertical asymptotes. So if I do that, x squared equals 0. I'll actually do that right on here. If we have x squared equals 0 and I want to solve that, I would take the square root of both sides. When I take the square root of 0, I just get 0. So x equals 0 would be the only thing that can't be in my domain. All right. I cannot cancel that x out with anything up top, so it is going to be a vertical asymptote and there's going to be no holes on that graph. Okay. For our horizontal asymptote, if we look at this, the degree of the top, there is no x value. On the bottom, the degree is 2. So the degree on the top is less than the degree on the bottom, which following our rules gives us y equals 0 as our horizontal asymptote. Now for number 10. Again, there is no factoring we can do here. So what I would do is just take this bottom and set it equal to 0. If I do that, okay, x minus 2 cubed equals 0. Okay. To get rid of this cubed, I would take the cube root, which will cancel out with that cubed. Right? And we should know that the cube root of 0 is going to be 0, so we have x minus 2 equals 0, and we just have x equals 2. So we know x equals 2 cannot be in our domain. X cannot equal 2. It can't cancel out with anything on the top, so we have a vertical asymptote. Okay. And then for a similar reason with the last one, the degree on the top is less than the degree on the bottom, so we would say we have a horizontal asymptote at y equals 0. Okay. And then number 11, okay, on the bottom, we can't factor this at all. Okay. So then we take the bottom, set it equal to 0. If I do that, I get x equals 5. That would make the bottom 0, so that is not part of our domain. Okay. I can't cancel it out. It would have to be the same thing that we have on the top and the bottom, and that is not the same thing, so we can't cancel it out. Therefore, it is a vertical asymptote. Okay. Now, if we look at this, our degree on the top and the bottom, our biggest term on both the top and the bottom is x. Both of those have an exponent of 1. So we're looking at when n equals m. Right. If we look at the numbers in front of those two terms, 1 and negative 1. Okay, if we do 1 divided by negative 1, we get y equals negative 1 as our horizontal asymptote. Okay. Moving on to number 12. Again, this is one that we cannot factor. Okay. You can see here how I set the bottom equal to 0 and solved for x. Again, this is something that we can't cancel out, so that is going to be a vertical asymptote. If we look at this one, our degree on the top and the bottom for both of these is 1. So we look at the numbers out in front. We have negative 7 over 2. Y equals negative 7 over 2 is going to be our horizontal asymptote. Moving on to number 13. This is where these get a little more difficult. Okay. This one in number 13, we can actually factor the bottom. I can factor an x out of both of these terms. Pull out an x out in front, and what you can see here is I actually canceled out the x with one of the x's on top. Okay. Because that x canceled out with the top, I said that we are going to have a hole at that value. Okay. If I had set both parts equal to 0, okay, from this I would have x equals 0, and from this I would have x minus 1 equals 0. Okay. This one canceled out, so that's a hole. This one did not cancel out, so that is a vertical asymptote. Okay. If we now look at our horizontal, we see how the degree on the top is greater than the degree on the bottom, so therefore, following our rules, we have no horizontal asymptote. Number 14. Okay. We can't factor the top or the bottom. Okay. There's nothing we can cancel out, so I would just take the bottom and set it equal to 0. If I did that right here, x plus 2 equals 0, I get x equals negative 2. That is going to be our, oh, I put 2 on here. X equals negative 2 is going to be our vertical asymptote. That it also cannot be in our domain. If we look at the degree of the top and the bottom, the degree of the top is greater than the bottom, therefore we have no horizontal asymptote. Okay. Number 15 was probably a challenge for you guys because you had to factor on the bottom with a 2 out in front. Okay, so that might have been hard to factor. Hopefully we tried this. Okay, but when we do factor, we are left with this here. Okay, and we see how we can cancel out those x plus 1s. So where we have x plus 1, okay, that gives us x equals negative 1, which cancels out, so that is going to be a hole. As we can see, I wrote it right over here. Okay. And here, 2x minus 1 cannot cancel out, so I know that that is going to give me a vertical asymptote at x equals 1/2, which you can see that I also wrote right here. Okay. Both of those are not in our domain. One is a asymptote, one is a whole. Okay. Now looking at our n and m values, the degree on the top is the same as the degree on the bottom. Okay. So we look at the numbers out in front, 1/2. We have a horizontal asymptote at y equals 1/2. So that is the homework and the notes here. If you have any questions, let me know. I will also post both of these on Google Classroom so that you can take a look at them.